today, we're going to be doing some more graphing like we've been doing with the quadratics, making our parabolas, but we're going to start looking for some other information. Now, hopefully we remember at this point how to do certain things, like find the vertex and then just build our parabola from it. So like for instance here, it's just our base graph, our parent graph. And our parent graph always starts at 0, 0, unless there's shifts, so I can get that in. And we're going to look at this in the calculator too, in case you're like, yeah, I never did quite get what you were doing before. When we're building a parabola, we found that there was a pattern before. And basically that pattern is from wherever our first dot is, if I go right 1 and up 1, or over 1 and up 1 is what we called it, and I do the same thing on each side, I'm going to end up with this parabola that's symmetrical. So over 1 up 1 and then over 1 up 3 will get us enough points to be able to connect the dots and make the line. Now again, if you forget that sometime and you're in here or somewhere where you've got access to a calculator, I can always, and again, my X button, I might not be used to this with all this other stuff, but X is the first thing, so I can use that. And to see it, I can look at the picture. Okay, it kind of looks like what I have here. But if I want to look at the actual points, I just hit second before I hit that graph button. And what I'll find out is, if I put my vertex in the middle, which is 0, 0, check out my dots. I have dots at 1, 1, and negative 1, 1. I see both of those in my chart. I have dots at 2, 4, and negative 2, 4, just like I see in my chart. So the chart can help you on the calculator too. And I can go ahead and connect the dots. And I know some of my information already. One thing I know, my vertex was at 0, 0. Okay, it's always where the direction or the value changes, like it says here. What's the name of the point where the y value of the function changes direction? It's going down. Oops, now all of a sudden it goes up. Okay, that's my vertex. Oops, moved it a little out of the way there. The thing we haven't been talking as much about are all of these intercepts and these things called zeros. Okay. Here's how this works. The y-intercept is where x equals 0. I look to see where my graph crosses at x equals 0, which in this case is right here. So for this one, my y-intercept happens to be at 0, 0. So where does it cross the y-axis is another way to look at it. If I have a picture, it's easier probably to just look at it that way rather than worry about what the x value is. My x-intercept, in this case, is where it crosses the x-axis. So what we're going to be doing here, again, well, it happens at the same place. That won't happen every time, but it's going to happen sometimes. So when we're doing this, thank you, we're going to be looking for those two values. But here's the new one for us. Okay, we have these things called roots or zeros, and they're actually the same thing as my x-intercept. It's just a different name. And what this means is this would actually solve the equation where the two sides would equal. It's going to be my answers. Now, sometimes it may be several places. In this case, there's only one place. So x equals 0. You're like, well, wait a minute. What do you mean that's the answer? If I were to plug in 0 for x, okay, these two sides would end up being equal because my y value would also be 0 there. And I can find a solution. So sometimes there may be one, sometimes there may be more than one. And we'll see some examples of both. Now, can you remember? Let's see if our memories are serving us well here. My vertex down here, is that a minimum or a maximum value? Minimum. And we know it's a minimum because if our parabola opens up, that changing point's the least value we have. If it would have been a maximum, it would have opened down, and that value would have been up at the very top. So that's what we're kind of trying to work ourselves out with here. And so our other two names for the x-intercepts, which are going to show up more often on your worksheets and probably the test too, is either root or 0. You could see it called a solution, but most of the time it's going to be called one of those things because we're just looking. So it's really not that different from what we've been doing. Still graphing, we're just finding a little bit more information from it. You're like, ooh, Harty, you crossed out a couple of words. And yes, because our main focus right now is on the intercepts and those zeros. And we can get all of this information just from what we've done before. Like for instance, before I worry about all this other junk, because this is kind of review for us. What's my vertex going to be? Because this is in vertex form. Remember? Do you remember? Do you remember? When we're looking in vertex form, it's the opposite of what you see in the parentheses. So I see -5, so the opposite would be 5. But I keep whatever's on the outside. So my vertex is at 5, -8. And I know it opens up because it's positive. Now here's where I got to be careful if I'm going to try doing it without help or without making a chart or without the calculator. Normally I know we go right 1, up 1, or over 1 and up 1. But with my A value in the middle being 2, it means my pattern, I go up that many now. So I go over 1 and up 2. Okay, over 1 and up 2. And you're going to multiply whatever that up number is. So normally next I'd go over 1 and up 3. Well, 3 times 2 is 6. So I got to go over 1 and up 1, 2, 3, 6. Over 1 and up 1, 2, 3. And again, if that's something you're kind of sitting there shaking your head going, okay, why do you change that up? I'm not quite catching on. Again, normally our pattern is over 1, up 1, over 1, up 3. But if there's a number in front of my x squared, or in this case the parentheses, whatever that number is, we're going to multiply that by our A value, by whatever number's in front. So that's why I went over 1, up 2 for my first ones, and over 1, up 6, my A value is 2 for that next one. Now again, I always have a backup plan. I always can go ahead, let me squeeze this over so we can see the equation a little better, where I can type it into the calculator. Make sure I get everything in there right. Don't want to have something bad going in. I graph it, okay, mine looks like it's about the same. It's over to the right and down, okay. And then I always can double check, but my vertex has got to be in the middle. So this 5, -8 needs to be in the middle. There it is. And then I check my other points. 1, 2, 3, 0, yes. 4, 5, 6, 7, 0, yes. 4, 1, 2, 3, 4, 5, 6. And there's my -6s, so I know I did it right. Cool thing this time, now I don't notice my y-intercept. We'll come back to that in just a minute because there's an easy way to find that. My x-intercepts, where does my graph cross the x-axis at? What x values? Because there's 2 this time. What are my 2 x values here? One here at 3, and then 4, 5, 6, 7. And those are also my roots, or my zeros. Those are my solutions to this. It's opening up, so I know my vertex is a min this time. And then like, well, y-intercept, I can't see where it crosses the y-axis at all. So what do I do then? Here's our backup plan. If I can't see it, okay, I'll get my graph up here. I can hit trace, and look what happens. X equals 0, which we set up above, is where the y-intercept is. Now see, I'd have never seen that on my graph forever. Why, 42? Holy cow, man. So my y-intercept is at 0, 42. I'm just going to hit the trace button. Like, well, what if I don't have a calculator? What would I do? Well, if I have no calculator, I'm going to substitute x equals 0 into the equation. And when I did that, I'd end up with the same answer. So I do not have to have, and I'll move this over here so you can still read there, I don't have to have a fancy calculator to be able to do this. I could, with any calculator, I could stick in that 0 for x. And there's my 42 that I would need for my y-intercept. So I can still find it that way. So again, calculator, no calculator, we're good. All right, one more in vertex form. Then I think we got one in standard, and I'll help you out get going on the packet here. Okay, vertex. Now this one's a little trickier. If there's no number outside, I act like it's a +0 out there. So again, when I'm figuring out my vertex, it's the opposite sign of what I see here, so that'd be -5, and then whatever value's on the outside. So -5, 0, we'll get that in. Then, when I go to graph, I gotta look at that value in front again and remember my pattern. So it's over 1, but my a value is negative this time. So over 1 and down 1. Over 1 and down 1. And that's all because of that value in front, my a value being negative. And then over 1, down 3. Yeah. And I can connect the dots. And wherever that's at, that music's way too loud that I can hear it. Yeah, Poe can help me. Too loud that I can hear it all the way over here. Thank you. Appreciate it. So, I notice a couple of things. I notice this time it's opening down. So my vertex is going to be a maximum value. Now we'll come back to y-intercept here again in a minute. X-intercept happens to be my vertex this time. That can happen. And notice sometimes we get 2, sometimes we only may get 1. So just because I put 2 blanks there for my roots or my zeros doesn't mean there's going to be 2 every time. There could be, though. But again, for my y-intercept, I have choices. If I've gone ahead and I've plugged this into my calculator and I've got the graphing capability, I'll let it do the work. That's fine. I can put on the +0, but I don't have to. Opens down, okay. Oops, undo that. And I can hit my trace, and there's my y-intercept. But again, if I don't have a graphing calculator, it doesn't mean I can't do it. It just means now I just type this in and I use a 0 where the x is at. Get the same answer. So that's all we're really doing with these. I know there's a lot of steps to it. That's why we're kind of jotting some of these things down. But a lot of this really should be review type things for us that we're working through on these. I'm going to change these real quick for later reference, okay? So if I go to the back then, the last one we're going to do right now up here is number 4. Okay, I'm not going to worry about 5 and 6. They're in a different form we haven't played with yet. So here now, this is a little different. This could also be written negative x plus 0 squared plus 3 if you want to see it, oops, get on the screen here, in the same format. And all this means is, since there's no parentheses, my x value, my vertex will be 0. It's not going to move. It's just going to be the up 3 portion, because we keep that part on the outside the same. So 0, 3. Yep. Nice big dot there. And then I look and I see, ooh, that value in front's a negative 1. So we're going to go over 1, and since it's negative, we're going to go down 1. We're going to go over 1 and down 3. And the pattern just continues that way. As long as we have those 5 dots, we're in good shape. So then I look and I'm like, okay, now this is getting a little more interesting. Because I can see where my y-intercept is. It's at 0, 3. I can see it's a maximum because it's opening down. But this time, I don't see dots on my x-axis anywhere. Now I wonder if I put it in the calculator if it would help me more here. Let's find out. Because I still have a backup plan if this doesn't work. Okay, it looks like the same graph. I look at the chart. Okay, I want 0 in the middle. I don't see any zeros for y, so what am I going to do? Well, there's a couple of things I can do. Here's my idea. And this could get a little complicated, but we can do it. I can do one of two things. Either on the calculator, we can trap those zeros in, but I'm not going to force you to have a problem somewhere on like a quiz or a test where you have to do that. So here's the easier way to go. To find my x-intercepts, remember we're going to use y equals 0. So we're going to do a little math work here. So we're like, okay, if y equals 0, there's my equation. So I've got 0 equals negative x squared plus 3. And I got to solve this little mini equation. This is going to lead us into what we're going to be doing right after this. So I want to get x squared by itself, of course. Since it's negative, I'm going to go ahead and I'm going to add the x squared to both sides to get it by itself. You're like, now why didn't you just minus the 3? And I could have. But what would happen if I did that was I'd end up with all these negatives. At least this way everything's positive. Anybody remember how to get that squared off of my x? What's the opposite? It's the opposite of squaring something. It has the same word in it. Square root, nicely done. So I'm going to square root it. And you're like, ooh, I'm going to get a funky answer here. Here's the other thing I got to remember. So you're like, square root of 3. Yeah, I don't know what that is. Let's go decimaling here. So 1.73. But again, it's plus and minus because I see there's 2 spots here it's going to be. It's going to be both of these. And those would actually be my zeros. Eee. Not always fun, but you know, we'll survive with it. And that's how this one would work. That would be the way I'd do it. I wouldn't try to play with the calculator trapping it. It's too much work. So here's what we're going to do. We are going to, as I slide this by here, I want to do a couple of these with you on here just to kind of see. And I'll tell you, we're actually going to eliminate a couple of problems on here too. Let's take care of that part first. we are going to eliminate or skip, let's write this at the top here, because we haven't done a lot with root form yet, so I don't want to force you into that. So we're going to skip 2, 6, and 9. Which brings us down to, I believe, a grand total of 6 monstrous problems on this particular one. And this is going to be our first assignment for homework check number 12. So if you're still playing around with some different ones, homework check number 12, first assignment is what we're going to be looking at here. So let me get that guy out of there. And we'll do these first couple. We'll do 1 and 3 here, and then kind of get going from there. So, okay. Remember, if there's nothing outside the parentheses, we've got a big old plus 0 there, which is nice because it tells me the vertex, the opposite of what's in the parentheses, so it's not -4, it's positive, and whatever's outside. 1, 2, 3, 4. Get that big old dot in there. Okay, I don't know all my other information yet, so I'm going to graph it. There's no number in front this time. Great. So I know it's just the regular pattern. It's over 1 and up 1. Over 1 and up 1. And then over 1 and up 3. Over 1 and up 3. Okay, and I'll draw that in. I'm going to try to do this one completely without the graphing calculator. If I got to use the regular part, that's okay. So I look and I'm like, okay, what can I see right away? Well, I can see my x-intercept is right here, 2, 3, 4. So my x-intercept is at 4, 0, because that's where it crosses the x-axis, hence the word x-intercept. But that's also my root. Because again, my roots are just my x-intercepts, except it's just the x value. So it'd be 4. Now my y-intercept I don't see so much on here. So remember for that, we're going to plug in 0 for y. And it's okay to use the calculator, I'm just not going to use the graphing function. So I look and I say, okay, so 0 equals x minus 4 squared. And we just got done saying the opposite of squared is square root. So I'm going to do that right away because there's parentheses I need to be able to get rid of. And the squared and the square root will wipe each other out. I can even handle this. Square root of 0 is 0. And since the squared and the square root cancel, I'm just left with what's underneath. And I would say we're all very, very capable of knocking out this one-step equation. To get x alone, I'm just going to plus 4 to each side. They're like, Harty, you're going to grin at me in a minute. What did I do silly? Did any of you know?
You already found that.
I did the opposite. I found my x-intercept. Oh. Oh. And I'm forever going to be forever. Well, I don't have to have that error there forever. This error may be forever out on the interwebs. But it goes to show that even the math guy can do some silly things sometimes here. All right, let's do this correctly here. You got to plug in the 0 for the opposite of what you're looking for. All right, let's try this again. Y equals, and if we need to room over here, you guys can. So 0, that's better. Minus 4 squared, that's much better. Make sure the parentheses are there, though, if you are putting it in the calculator. So we do 0 minus 4 squared. That's better. And again, if you wanted to, if you did have access to the calculator, which you would in here on any quiz or test anyway, if you have it graphed and you just hit trace, okay, that would get you the same answer and you'd have that done. So I apologize taking it down a bad track, but it's easy to see. It was pretty easy for us to recover. So we got that one taken care of. And then we'll jump down to number 3, and then I will set you on your own here for a bit. All right, so number 3, my vertex opposite, keep it. Okay, that's the big thing. Got to remember the opposite for that x value. So -1, -4. Get my big dot there. Okay, I don't know much other information yet except, oh, my a value is 2. So remember, over 1, but not up 1 this time, up 2. And then over 1, but not up 3. Remember, multiply it by that. 3 times 2 is 6. So over 1 and up 2, over 1 and up 2, over 1 and up 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Get my graph drawn in. I see my y-intercept right away this time. It's dot right here. So 1, 2. So 0, -2. I don't think my x-intercepts are going to be pretty this time, though. That's okay. I can make this work. It might get a little tricky, but I can make this work. So again, if I'm looking for the x-intercept, I set my y equal to 0. So we're going to do a little algebra this time. But we're capable of doing this because this has been one of your guys' expertises from the beginning. The equation solving's been really good. So here's what I got to do. Whatever's the furthest away from x is what I got to get out of there first. So since the furthest thing away is this -4, I got to add 4 first. You're like, well, could I do the square root thing first? Not in this case. I can't do that until the parentheses are by themselves. So we got a little work to do here, but it's okay. We're going to get there. So then I look and I say, okay, I got that out of there. Is there anything still in the way of my parentheses? Crap, this 2's still here. But I'm multiplying by 2. So I do the opposite. I divide by 2. Because again, we're trying to get the parentheses alone. Oh, we're almost there. Finally, the dreaded parentheses are alone. Now I can do my opposite of my squared. And I got to keep track of one thing here, but we're gonna remember this. We're gonna make ourselves a note of this in a second. Okay. Remember, when you take the square root, it's plus and minus. You're like, well, what does that mean? Well, I notice when I'm looking at my graph that there's 2 places that it crosses the x-axis. So here's how I do this. If I was just trying to get x alone, I'd minus the 1 at this point, and I'm going to get this funky looking answer. And at first I'm going to be like, how you do this? I'm just going to come up with each answer separately. So here's what I mean. So we are going to have to do a little calculator work here. Even though I'll be honest, we could leave it in that plus minus, but so I do like -1 plus the square root of 2. Okay, that's one of my roots. That's one of my answers. And then I do -1 minus the square root of 2. And that's going to be my other root. And if I wanted to write the x-intercept, I could. I just would put it in a coordinate form. But like I said before, I won't put it where you've got to deal with the radicals on the test. But it's not bad to have to deal with some here, because when you get to your next math class, if some of you are double dipping it this year and are going to be looking at Algebra 2, this is going to happen sometimes. So your job is to fight through those other 4 problems, and then tomorrow we're going to do some of this at the start. We're going to get a worksheet, no other notes with this, and just kind of work through it some more, and then I'm going to start throwing some more of this solving the radical stuff at you just to help you with it a little bit and make that go a little bit better. But get yourself the